When the James Webb Space Telescope, or JWST, turned its powerful infrared eye to a tiny sliver of the night sky, it observed something entirely unexpected: structured, rhythmic light pulses originating from a point approximately 7 trillion miles away. The scientific community was stunned. These lights, faint yet consistent, bore no resemblance to the random twinkles of stars or the erratic flickers of distant quasars. Instead, they appeared almost familiar. The patterns resembled city lights, structured beams organized in linear bands and circular clusters, a geometry far too orderly to be attributed to a natural cosmic event. This observation sent shockwaves not only through the field of astronomy but across every major scientific discipline. It defied current understanding of celestial phenomena and raised profound questions. The James Webb Space Telescope, the most advanced space observatory ever launched, wasn't built to find signs of alien life. Its primary mission was to look back into deep cosmic history, to study the birth of stars, the formation of galaxies, the atmospheres of distant exoplanets, and to identify clues related to their habitability. But with its unmatched sensitivity in the infrared spectrum and resolution that far surpasses its predecessors, it has repeatedly delivered discoveries beyond expectations. In this particular case, what it captured wasn't a nebula or a galactic swirl. It was a tiny patch of sky containing a pinpoint of light exhibiting patterns that were remarkably similar to artificial illumination. To truly grasp the scale of this event, one must consider the distance involved. 7 trillion miles, or about 1,100 light-years, puts this light source far beyond our solar system and well into the interstellar medium. At that distance, any signal would be incredibly faint, having traveled through centuries of cosmic interference, through clouds of dust, waves of radiation, and even gravitational lensing effects. And yet, JWST managed to isolate the light, map its structure, and confirm a consistent pulsing pattern across multiple observational windows. What baffled astronomers most was the structure of the light itself. Natural sources like stars or brown dwarfs emit energy either continuously or with emission and absorption lines corresponding to their elemental makeup. But this light didn't conform to those rules. It repeated in precise, timed intervals, a synchronization pattern suggestive of a grid or structured system. When the data was reconstructed and compared to satellite imagery of Earth's nighttime cityscapes, the similarities were uncanny. The light showed variation in brightness, repetition of distinct patterns, and formations that hinted at something artificial, even zoned or architected. These weren't random emissions. They seemed to mirror the kind of illumination produced by intelligent urban design. This single observation cracked open a new realm of inquiry. Could this be evidence of an advanced civilization unintentionally revealing its presence through the byproduct of its infrastructure? Could this moment represent humanity's first, indirect glimpse of life beyond Earth, a life that had reached a technological plateau, enabling it to alter its planetary environment on a massive scale? Scientists around the world began dissecting the light more closely, breaking it down into thousands of data points. They analyzed heat signatures, spectral anomalies, and waveform consistencies. Their findings were even more compelling. The light was not merely reflected starlight nor refracted by cosmic dust. Its intensity shifted with such regularity that it suggested energy use, possibly even energy management at the planetary or megastructural scale. Patterns mirrored power consumption curves seen on Earth. Light emissions increased and decreased in cyclical rhythms, reminiscent of daily urban activity, strong during presumed daytime hours, tapering off at night, then rising again. The spectral analysis went deeper. Reflected light revealed chemical markers in the exoplanet's atmosphere that included nitrogen dioxide, sulfur dioxide, and even chlorofluorocarbons, compounds which, on Earth, are primarily industrial byproducts. These substances are not known to form in large quantities through natural processes. That realization changed everything. It wasn't just light anymore, it was pollution. It was evidence of a biosphere, or more provocatively, a technosphere, being shaped by intelligent life. The implications were massive. If this light was indeed artificial, then Earth was no longer alone in bearing the visible signature of a species altering its own world. This validated decades of speculation among SETI researchers and astrophysicists who theorized that advanced civilizations, if they existed, might be detectable not through active communication, but through their environmental impact, through unintentional leakage, like light. On the Kardashev scale, such a civilization might approach Type 1, a society capable of harnessing the full energy potential of its planet. What was once theoretical now seemed plausible, even observable. This singular point of data redefined how we approach the search for extraterrestrial intelligence. Instead of scanning the stars for radio waves or listening for deliberate signals, we could look for patterns in something more omnipresent, light structured by planning, engineered by design, and possibly reflecting cultural aesthetics. The arrangement of the light patterns wasn't haphazard. It appeared to follow some internal logic, possibly a layout akin to city planning, grids, rings, clusters, perhaps even something artistic. For decades, the search for extraterrestrial intelligence focused on narrowband radio signals, hoping to hear a deliberate hello, but this event demonstrated that light, its organization, modulation, and interaction with the environment could be the most natural and universal signature of intelligence. It was as if we'd spotted the faint outline of a distant coastline and seen the unmistakable geometry of street lamps lining roads we had never imagined reaching. As more observational data streamed in, astronomers confirmed that the light source resided on a planet orbiting a sun-like star. That planet existed within the habitable zone, not too hot, not too cold, and appeared to have a substantial atmosphere. Thermal mapping revealed hotspots, or heat islands, potentially signifying concentrated energy usage. These heat anomalies correlated precisely with the patterns of pulsing light, strengthening the argument for technological origin. But it didn't stop at visuals. Faint electromagnetic emissions were also detected, spanning non-random frequencies. While they carried no discernible message or data signature, their steady presence hinted at ongoing technological activity. There was no call for contact, no deliberate signal, only the persistent hum of machines and the glowing mark of a civilization going about its business. The most humbling element of this discovery, however, was temporal. Light from 1,100 light-years away means that what we're seeing occurred more than a millennium ago. We are witnessing a moment frozen in the distant past. Whatever species lit up that world may have grown more advanced since, or they may no longer exist at all. But even if they've vanished, their lights remain, reaching us across time as proof that we were never alone in creating artificial brightness in the cosmos. This realization sent tremors through philosophy, astrobiology, theology, and ethics. If another species had achieved this level of complexity over 1,000 years ago, then intelligent life may not be rare at all. Perhaps, given the right conditions, it's inevitable. Maybe the lights we saw are just the first of many. The cultural weight of this cannot be overstated. For centuries, humanity has gazed into the night sky, weaving myths, writing poetry, and searching for meaning in the vast darkness. To now anchor those dreams in reality is transformational. The observation reshaped entire scientific disciplines. Even our perspective on our own cities shifted. What we once considered ordinary, city lights, are now potentially messages in a cosmic language. They signal more than development or energy use. They indicate intelligence, perhaps even consciousness. One day, perhaps, some distant observer will see Earth's own glow from across the stars and wonder the same things we do now. Who are they? What are they like? What kind of world do they live on? This event also ignited curiosity about the possible technologies powering those lights. Could this civilization have harnessed nuclear fusion? Do they still burn fuel, or have they developed energy transmission systems far beyond our comprehension? The consistent intensity of their illumination suggests remarkable efficiency. Could their structures glow with bioengineered light? Do their cities float, suspended by forces we have yet to understand? We don't yet know, but now we have reason to ask.